Hi there, in this video we are going to be working with logarithmic equations, kind of just getting to know the basic ideas of what logarithms are. They are the inverse of our exponential equations that we've been working with recently in class. So let's go ahead and get going and talk about just the basic relationship of what a logarithm is related to an exponential. So here I have set up the definition that you've probably seen in class or in your textbook, that log base b here, of x is equal to some value y. So the exponential representation of this would be I take my base value b and I'm going to raise it to that power y that we had that logarithm equal to. And then this will be equal to the argument that was inside our log. So this can kind of seem a little weird that the definition of a log is related to this other relationship that we've been getting accustomed to, but we'll kind of see how this works all together here in the next few slides. But before we move on, a big caution here is that the log base b of x is itself a number, and we are not multiplying here. So I'm not taking whatever log base b is and multiplying it times the argument x. It is actually itself altogether a number, and we're going to see a bit more of that here in the next few slides. But for example, log base 2 of 8 is equal to 3. So it is a number, and I could even plot that number on a number line. So it exists as a number itself, right? So let's go ahead and maybe write down this definition if you haven't already, because we're going to be applying this relationship here in the next couple slides. All right. So what I would hope is that you can pause this video and go ahead and try as many of these as you can on your own, and then I'll go ahead and walk through them with you. All right, so hopefully you had the opportunity to convert each of these exponential equations to their equivalent logarithmic equation. Let's go ahead and just start here with part A. So what we always will start with is on the right side of this equation in part A, I see that 5 being raised to a power. And so if this was just the exponential equation we were talking about, we would know that 5, we'd recognize 5 as the base value here, and it's being raised to a power of 3. And so I'm going to use that knowledge. What I want to start with is writing out, of course, log, there we go. And I'm going to take that knowledge of the base value 5, and I'm going to put that 5 just down a little bit lower than the log itself. That's where it likes to sit. And then I need to put the argument here into the log. And so it's going to be the opposite of what I see in the exponential. It's not going to be 3. It's going to be 125. And so this will all be equal to finish off, going to be equal to that original exponent, right? And so if I wanted to read this out, I would read it as if it was an exponential. I'm saying 5 raised to the power of 3 is equal to 125, or in logarithmic form, log base 5 of 125 is equal to 3. So moving on to B here, we're going to use that same principle we just did. Remember, let's go ahead and use the knowledge we have of exponents, that the 2 here represents the base that we're raising to a power of 4. In logarithmic form, we're going to put that 2 down here as our base value. And then our argument for the logarithm, what I'm putting on the inside of the parentheses, is going to be the 16, right? And this will all be equal to the original exponent of 4. So maybe by now you've seen a little bit of a pattern arising here. If you wanted, let's go ahead and write out the exponential form here of that definition we were just looking at. And remember, we were talking about logarithms being the inverse of our exponentials. And so when we were talking about inverses, we're switching our x's and our y's. So let's go ahead and jot down what I started with before was the idea I'm going to take that base value and put it in my logarithm. And then the next step is just switching the x's and the y's, right? That's a nice thing about inverses. We just swap the x's and y's, right? So go ahead and, oops, I don't want to do that here. Let me go ahead and erase that. Simple enough, but it can be easily mistaken here. So as I was saying, after putting down the base value in our logarithm, we're going to go ahead and just plug in our x into the argument, and our y is our output here. Okay, so let's go ahead and try C together. So what I again want to do is I'm going to start with plugging in the base value here. And so 3 is my base value. It's being raised to the power of -2. And then I'm going to plug in my x and y here. So this guy is equal 1/9, so that's going to be now the argument of my logarithm. And then the output here is going to be the original input of -2 into the exponent. So this guy would be read as log base 3 of 1/9 is equal -2. All right, last one on this page. Let's go ahead and start with our log. Write down the base value. Looks like the base value here is 6. And then I want to plug in the output of the exponent above. That 36 is now going to be the argument of my logarithm using that kind of inverse idea. And then this will be equal to the original exponent. So here this is equal to x. All right, so let's go ahead. Hopefully you got time to practice these. Let's go and try the reverse of this. Let's go and we'll try to conversion. So if you would like, go ahead and pause the video and see how far you can get with these. All right, so hopefully you had an opportunity to try these out on your own and made it through. Let's go ahead and try converting these back into the exponential form. We can lean very heavily on what we just did, right? What I did initially was I recognized what the base value was when I was converting from exponential to logarithmic. So here I'm going to recognize the base value. So remember that logarithm is set up that the b value is my base, the x value is the argument inside the parentheses, if you use parentheses for your log, and then this will all be equal to my output, or y. So here, if I'm converting, I'm going to start with my base value. So I'm going to write down my 2. And then remember that we're going to talk about this, or we're thinking about this in terms of the inverses, the inverse relationship here. And so what I see here is that my original 16 is going to be the output now. And the output from before is going to be the input into the exponent's position. Which this makes sense if I were to sit here and take 2 times 2 times 2 times 2, right? 2 to the 4th power is equal to 2 times 2 times 2 times 2. And if you had your calculator handy, you would know that's equal 16. Okay, so let's go ahead and try B here. Again, the first thing I'll do is I'll recognize what the base value is. And so my base here is a letter. So hopefully you've seen this letter. I'm sure you have, right? This is the number E. And I'm going to be raising it to the original output of my logarithm. And that was x. And the output of this exponential form is the input of the logarithm, that inverse relationship. So I have e to the power of x is equal 10. All right, so part C, it looks like my base is 5. So again, I'm going to start with writing 5. I'm going to raise it to what the logarithm was equal to, right? Inverse relationship happening there. And then this is all going to be equal to the input of my logarithm, x. Okay, so last one, part D, we have the log base 10 of 0.1 is equal to -1. Again, I'm going to start with my base value of 10. I'm going to raise it to the output of the logarithm, and this will be equal to the input of the logarithm. So 10 to the power of -1. We know if I wanted to get rid of that 10 to the power of -1, I would go ahead and put the 10 into the denominator. It still has an exponent of 1, but I know that 10 to the power of 1 is equal to 10. And most importantly, when I put the 10 into the denominator, the exponent becomes positive, right? So if you had your calculator, or if you know from experience, 1 divided by 10 is equal to 0.1. So great. I'm glad that you were able to practice these. Hopefully that made sense to you. So let's go ahead and give us a little challenge here. Let's try to evaluate some logarithms together. We're going to go ahead and try our best to evaluate each of these logarithms without a calculator. So go ahead and pause the video and just try to apply maybe some of the understanding you have about logarithms and their inverses, exponentials, and see what you can come up with. All right, so I hope you were able to try these out. I'm going to go ahead and maybe, let's think about this. The first one in part A, I've got log base 2 of 8, and I want to know, well, what does that equal, right? So one of the things that I can do is I've been working with this definition of a logarithm, right, and how it's related to its inverse, the exponential. So let's go ahead and think about it for a second as an exponential, right? Again, I start with the base. That's the common theme that we've seen throughout this video. Is I'm going to start with my base value. Here it's 2. I'm going to raise it to the power of some unknown value, right? So 2 to the power of something is going to be equal to the argument of my logarithm, right? 2 to the power of what equals 8. Well, you know, multiplying 2's together, that's not too bad, right? I can say 2 times 2. I know that's equal 4. And then if I multiply 4 times 2, I get to 8, right? 2 times 2 times 2 is equal to 8. And I could write this as 1, 2 raised to a power, and that would be 3, right? There's 3 2's here. And that's equal 8. So here, this guy, log base 2 of 8, is asking 2 to what power is equal to 8, the argument of my log, and that's equal 3. Great. So go ahead, if you haven't tried it yet, try B. So what we're going to do here is we're going to again start with the base, right? And I'm asking, well, 3 to what power is equal 27? And if we're not using a calculator, right, we can kind of just multiply by 3 here, right? 3 times 3, that's equal 9. And then if I multiply 9 times 3, I get to 27. Right? So here there are 3 3's, and I don't want to write out 3 3's every time, so I'm going to use the exponent to my benefit. Right? And so now it's just simply observing this is the exponential form, and I want to write the logarithmic form. And so I'll see that log base 3 of 27 is equal to 3. Another way of thinking about that is 3 to the power of 3 is equal to 27. All right, so I have 2 more challenging ones down below here. I'm going to start with the base 5, and I'm going to ask the hard questions, right? How many times do I multiply 5 together and get 5, or 5 to what power, I should say, is equal 5? And we know if I had to, I could write an exponent of 1. So here, this is the exponential form of my logarithm. I'm going to go ahead and just convert it by observing that the 1 in the exponent position is the output of my logarithm. So log base 5 of 5 is equal 1. And so anytime that we have log base b of b, so any base b, this will always be equal 1, right? Because b to the power of 1 is equal b. All right, so the last one, I think this one's a little bit more of a head scratcher. I'm asking 10 to what magical power equals 1, right? Converting the logarithm to an exponential, 10 to what power is equal 1? And so if you are well versed in exponents, you would know this, right? You'll have this right on the tip of your tongue. This is equal 0, right? That's that magical number. I can raise anything other than 0 to the power of, and I get 1, right? And so that is my practice I have for you today. I do want to take a second, if you notice that we have special notation for their bases, so you'll commonly see these written out. So if you see log of x without a base, so notice I have no base present here, it's just log of x, that's always going to be base 10. So we all agreed upon it. It's a common enough logarithm that we're just going to have a nice shorthand for it. So when you see log of x, that is log base 10 of x. And then the other one that's common as well, this is ln of x. We say this is the natural log of x. And so this guy actually has base of the number e. It shows up again, number e. And so it's also good maybe to realize, I had seen this earlier, right? Log base e of x. That guy is just another way of writing the natural log of x, right? Okay, so if you see that one show up, that's what they're talking about there. They're saying that the base here is e. All right, well, I hope you have a good day. Thanks for watching. Have a good day.